Let's solve the problem. Number 41. A block on the string is pulled to the right and released at initial moment of time 0 seconds. It passes one coordinate 3 centimeters at moment of time 0.685 seconds, and it passes another point negative 3 centimeters later at t equals 0.886 seconds. What is the angular frequency and what is the amplitude? First of all, the general equation for the oscillations looks like x coordinate as a function of time equal amplitude times cosine omega angular frequency times time plus initial phase 0. Before we start to solve these problems, we have to figure out initial phase value. We are given that at t initial moment of time 0, we have spring pulled to the right and then released, which means that we have maximum possible elongation from the equilibrium of the spring, and the maximum elongation of the spring from equilibrium is nothing else as amplitude. So at initial moment of time t equal to 0, we have that a equal our x equal a times cosine omega times 0 second plus 0, or a times cosine 0. From this equation, a equal a times cosine 0. After cancelling a, we will have that cosine 0 is equal to 1 and 0 equal to 0. So we have simple equation in which 0 will be absent. Next, we have to incorporate the data given to us in this problem in this equation. So we will have first equation 3 centimeters equal a amplitude times cosine omega times 0.8685 seconds. And second equation minus 3 centimeters equal a times cosine omega times 0.88 seconds. And we have to solve this system of two equations and two unknowns, amplitude and angular frequency. Let's first find angular frequency. You can do this by different ways, but probably the simplest one is we have to rewrite second equation multiplying by minus 1 left and right hand side as 3 centimeters equal minus a cosine omega times 0.886 second. Now our goal will be to move minus sign inside of the cosine function. To do that, we will use well-known for you equation or relationship from trigonometry. Cosine of alpha plus minus beta equal cosine alpha times cosine beta minus plus sine alpha times sine beta. Indeed, if you will pick up your alpha as omega times 0.886 seconds and beta as either plus or minus pi, you will immediately satisfy condition that sine of the pi is 0, so the second term will disappear and you will absorb the minus sign inside of your function. So our second equation can be rewritten as 3 centimeters equal a times cosine omega times 0.886 seconds plus or minus pi. Cosine of pi is -1, cosine of minus pi is -1, so it doesn't matter, you will have the same answers. Now, if you will compare first equation with our rewritten second equation, you will see that left-hand sides are the same, which means that the right-hand sides have to be the same as well. So I can claim that a times cosine omega times 0.685 seconds will be equal a times cosine omega times 0.886 seconds plus minus pi. You can cancel a, and you will see that you have two cosine functions equal to each other, which means that the arguments have to be equal to each other as well. So we'll have omega times 0.8685 seconds equal omega times 0.886 seconds plus minus pi. From here, it's not difficult to find omega. Omega will be equal plus minus pi divided by 0.685 seconds minus 0.886 seconds. Now, you have to keep in mind that omega has to be positive quantity, so after you find difference, you will have negative number in denominator, so you'll have overall positive value for the angular frequency only if you will have negative value in numerator as well. So you can claim that your omega has to be equal pi divided by 0.201 second. This is our angular frequency. To find amplitude, you can use either first or second equation, doesn't matter. Let's assume that we will use first equation. So you can claim that your amplitude will be 3 centimeters being divided by cosine omega, you did find already, times 0.685 seconds. And you did find both quantities, angular frequency and amplitude. We solved the problem.